Hello everyone, welcome to Having Fun with GPU Resets, Smiling Face. My name is André Almeida. I'm a kernel developer from Brazil, and I work at Igalia, mainly on the STNAC and the AMD GPU driver. So this may sound familiar. So you're playing game on Linux, and then something goes wrong, and then boom, you have just a black screen. You need to boot your machine to use your computer again. So yeah, GPU hangs are a real problem on Linux right now. So in the past months, I had an investigation and then trying to solve the problems, trying to figure out what's going wrong. So this is what happens if your GPU hangs on a discrete AMD GPU, usually. So that happens because modern GPUs are very, very complex. As Melissa showed yesterday, they have a lot of different features, a lot of different compute units, transistors, and on top of that, shaders are Turing complete. So you have a lot of undecided problems to know if your shader will stop eventually or not. So this is a pipeline just for the display of AMD. And the thing is, if you have an infinite loop in the CPU, it's not that bad, because the way that we abstract the CPUs, we kind of have isolation of the process and this kind of stuff. So it's very rare that one bad program can completely take down your computer, because the task scheduler will try to make everyone a chance to work on. We have memory isolation and CPU isolation. But on GPU, things are more bare-bone. Things are more close to the metal. Things don't have that much of abstractions. So a single graphical application can just take over of all GPU resources at the same time. So if you you have an infinite loop on the GPU, the display won't be able to update anymore. So now we're going to have a look at what happens from when a GPU hangs from the hardware to the application. So Mesa asks the kernel to submit a job to the driver, to the hardware. So the kernel drivers submit the job to the hardware. But as I said before, shaders are incomplete, so we have the halting problem that we can't really decide if a given problem, if a given program will ever stop running. So we need to check for fences to see if the program is doing progress, or timeouts. If something takes too long to run, we believe that this is going in an infinite loop, so we decide that the GPU is hanging, and then we try to kill it. And now the kernel drive needs to do the soft reset, so we can step out of this hang state. And this is very vendor specific. Each hardware supports different types of resets. So we have what is called soft resets that will only reset the context or the engine that has problems. And we also have full device resets. And for what I found is that discrete AMD GPU struggles with per context resets. It usually just go for a full reset on most of times. And that means a total loss of VRAM. So if your game crashes, probably GNOME or whatever composer you're using will also get crashed. Okay, anyway, now that the kernel driver saw that the hardware was stuck, we need to report that to user space. So now kernel and Mesa will talk together, but unfortunately DRM has no API for that. So what we have is each driver implement this in a different way. So for Intel, we have get reset stats. On AMD, we have context op carry. We also have MSM parallel faults. Some drivers just don't have a specific API as well. They just return error for I/O controls. And as far as I tried to find, I wasn't able to find any of these reset report for Raspberry or Vivante. But in fact, this part is not really hardware specific. We could have a common DRM API for that. That would be very helpful for the whole stack, as I will show later.
Okay, so now Mesa needs to talk to application that something went wrong. So some drivers, before submitting commands or issuing wait operations, they will ask the kernel if the device is around. And for Vulkan, if they find out that device is not around, they will propagate Vulkan error device loss above to the app. And then maybe the app can do something about that. If the app wants to be robust, they will recreate the context or just exit. And also we have an Vulkan extension that to query information about the reset, because error device loss it's an error code for a bunch of things, and you can make a lot of decisions around that. So we have this extension to explain what was the fault. So this is how Vulkan works. And on OpenGL, for the initial versions, there was no API for that, for robustness or to check if things went wrong on the hardware side. So OpenGL drivers, before they make a new context creation or to flush commands, they ask the kernel if a reset has happened. And if the app has ARB robustness support, it will propagate some kind of error to the OpenGL application. And otherwise, so this part is controversial. We don't have consensus in the community of what should we do if the app has no robustness. Some people believe that the driver should just kill the application because the application is misbehaving and is not allowing the user to have a good experience, is crashing the GPU. And other developers believe that it's better just to block the new calls for this app, but keep the app around because the OpenGL context is just a part of the application. So Mesa, as I show here, we have APIs. On the graphic APIs, we have ways to tell to application that something went wrong. So for Vulkan, is usually VK error device loss, and for OpenGL, we have the ARB robustness. And as I said, sometimes no robust apps are just killed, but even robust apps can misbehave and they can get in a broken loop. And Mesa and kernel, they can come up with policies to ban file descriptors if they keep resetting the GPU. So what I'm trying to show here is that the landscape is really complex, and we are trying to build consensus on what to do, but we have a lot of different hardwares and a lot of different strategies here. So if the application is really robust, it will recreate the context after a reset. So usually that goes like, oh, my submission returned a reset error, but this is just the GPU state. The CPU state, everything is preserved, so you have all the information that you need to create the states again, and then you can just keep going. And this is just a small shader that I wrote that if I run this on my AMD GPU, discrete GPU, it will just crash the whole graphics stack. It's just a small infinite loop. But I tried with different vendors and different OSs, and the results are very different. So what we can do here to improve the situation. So the DRM and Mesa is not really hardware specific. We could have something in common. And this would help because right now, both on the kernel side and Mesa side, for dealing with resets, everyone does something completely different. So it's hard to have a common code. If you found a bug, you need to check out the drivers if they have this bug or not. Yeah, common code is always not, usually a good way to go here, but we can't have that right now. And me and other user space and kernel developers, we managed to merge this patch to document DRM device reset expectations. So it should be on the next kernel release. It's basically DRM documentation explain what DRM drivers should do when a reset happens. And it's basically explain that if possible, the DRM driver should go for per context resets. And the interface of dumping errors is not dmask, it should be devcore dump. So you can hopefully someday integrate that with CI or something like that, so people can report better hangs. So I proposed this I/O control called DRM get reset, where we would have you ask for you give to the kernel context ID, and you ask the kernel how many resets this context has faced. And the problem with that is that we don't have a global context concept on DRM. Each driver understands context as a different thing. So that's why it was rejected. But it will make the driver, the user space side so much simpler. So every driver will just need to implement something like that. Would be simplify a lot. So if you find out that this context has some resets, that means that this context is the guilty one, so you can return that to user space. Or if you don't find any reset count for this context, but you find something for the device, that means that some other context had resetted the GPU. And what I found out in practice, that before there was no reset check at RADV, so I implemented the VK check status for RADV. So now RADV can tell applications that send application the error code when a reset happens. For Radeon SI, there was a reset check, but the driver would always return context reset forever. So the app would you would see that a reset has happened, so it would recreate the context, and then we would say to the kernel, hey, I have a new context, but the kernel would say, no, a context reset has happened, so you have this loop forever. So we fixed that as well. So for Intel, that is a reset check, but only notify the guild application that a reset has happened. And this works because Intel has a very good per context reset, but it's kind of tricky because if some other context is affected by reset, we'll have no idea that a reset has happened. So yeah, the application needs to be lucky to choose to alive. And as I said before, different kind of resets will have different impacts. So what I found out is we don't have much shared code, not much standardization, not a lot of end-to-end testing and validation. And each vendor reacts different to resets, and most of my experience is on AMD. The state for discrete GPUs is that it's usually unrecoverable for any kind of reset, but for APUs, like the Steam Deck, the reset is much more reliable. So you usually get a black screen, but sometimes you can do remote access and figure out what's happened. And as explained, Pierre from AMD and we work together to improve that for KDE, because as I said before, Radeon SI wasn't following the spec, it was just returning reset forever. But yeah, we need more tests here for sure. And on other OSs, you have a lot of more control of the stack, so they develop the user's kernel driver, user space driver, the compositor. Sometimes they only have only one compositor, so it's so much easier to standardize the behavior in all the stack. But on Linux, we have a lot of different things all over the stack. And a part of that, a part of telling user space application that a reset has happened, we would like to to give as much information as possible to the users, so they can reliably tell the driver developers what happened. Because right now, people just go to the issue tracker and say, this game crashed here. And I mean, it's hard to tell what happened there. And sometimes even this game crashed here after 20 hours of playing. So you're like, how can I reproduce this? So it would be very useful for driver developers if they had more information of what hanged the GPU in the first place. So yeah, they have a hard time figuring out what happened. And on top of that, GPU hangs, they have two main sources. So we have hardware settings. So on AMD, if the power management is too aggressive, it will change the voltage and frequency very often. And sometimes we don't know exactly why. This can put the hardware in a bad state, and we'll just hang the hardware. So the game itself wasn't bad or doing some infinite loop, was just out of luck. And of course, we also have application errors where your app does something that doesn't make sense, or so maybe get an infinite loop. And right now, there's no way to distinguish from those two. So yeah, we also would be very useful for us to have a way to know from the hardware to distinguish those two things. So ideally, we could deploy something with no overheads that we can enable by default, like on the Steam Deck. So every person playing on the Steam Deck will have a reliable way to send to Valve automatic report when something goes wrong. So I propose the AMD GPU Info Guild app to capture data about that. So you would ask the kernel after a reset what happened, and the kernel will show you some registers value, so you would be able to track which buffer was running when things crashed, or which instruction was the one that was running the moment that it got hung. But the AMD kernel developer, they replied to me that we can't really trust the register values after a reset. So yeah, we probably need some firmware support at this point to have something in the firmware that can reliably save the state of the hardware on a reset. But unfortunately, firmware is out of the scope of someone outside of AMD. So yeah, we need some comparison. And we have on Radv, we have the Radv debug hang option here, but it's not always effective because it inserts a lot of fancies and synchronizations and to the application. And sometimes when you change the order of things, the things just stop broken. So this option not always can be used to reproduce things. So we have now this challenge to how to get the information from the hardware in a reliable way and in a way that we can deploy to everyone. So all in all, the roadmap to have better GPU resets on Linux would be to have a better standardization of how DRM reports CPU hangs to user space, of how user mode drivers deal with hangs and with the Guild application, with the queue or not, the Guild application, and what compositors should do after a hang. And also, we need better hang log to show which buffer caused the hang in the first place, find a reliable way to dump the hardware state, and to use DRM driver should use devcore dump to deploy that. And also we need tests, a lot of tests all over the stack to find out, to keep track of that if resets are working. So here I have a bunch of links if you want to see the discussion that we're having. This is Windows after a GPU hang in the good days. And yeah, that was it for my presentation. Do we have questions? Charlie?
Yes. First, thank you for your presentation regard to the AMD GPUs. And actually, I'm from AMD and also work for the AMD GPU kernel.
Cool.
And you know, and we in AMD GPU from hardware side, we probably provide several types of GPU reset. You know, there is mode 1, mode 2, mode 0. So each level of a GPU reset, they have reset different hardware engines. I'm thinking whether, for example, the mode 0 we will reset everything, and the mode 2, mode 1 we will support each IP block in the MTGP kernel, and in mode 2 we will only reset graphics. Yeah, so how the user space driver can detect different reset type, or we will treat the reset all the same?
Cool. So first of all, I tried to find out which different mode meaning, what was the meaning of mode 0, mode 1, and I couldn't find that. So if you can document that, would be very good for me. But thanks for the information. And right now, there's no way to tell to user space which kind of reset has happened. We will need to add a new field to dev core dump, that this is what we are using right now to tell you to collect the log after reset. So yeah, we can talk later to I can show that.
Yeah, and also another question regard to we faced quite a few problems after reset. We were always some of user scenario we were lost the video memory. So that's a terrible thing. We cannot resume the VRAM. And how to recovery from the GPU reset after GPU. The challenge is from the resume from the GPU reset, right? And how to recover the video memory to make the user space can work smoothly after GPU reset.
Yeah, so the way to do that is with robust user space applications. So when the Mesa asks to the kernel if something bad has happened, the kernel will tell to the application, the kernel will tell to Mesa that a reset has happened, and Mesa will relay this information to the application. So each application is responsible for recreating their own contexts, and this is how you recover from a GPU hang. So, but yeah, we need to, everyone on the stack need to do that, basically. Everyone on the stack needs to be aware of that resets can happen and to be robust enough to recreate the graphics context. So that's why do we have those APIs. So user space can recreate everything.
Thank you.
So for non-robust applications, is there any reason why we couldn't just dump the contents of VRAM and then reload it after the reset?
To dump the content, so you would need to be sure that this information has survived a reset, right? The VRAM had survived the reset.
I mean, before the reset, you could save the contents of the memory somewhere, and then after the reset, restore it.
Okay.
Or is that impossible?
I don't know. I never thought of that, but that's in history. And so you would need to have something on the kernel side to manage that, like a swap thing, right? Yeah, I'm not sure.
Yeah, maybe I can answer these questions.
Sure.
In AMD GPU, we will have a shadow buffer to save the context before the reset, and can get resume actually, once we face the video memory lost, and then we can copy the shadow buffer into the original buffer. Yeah, that can handle by the kernel driver. Yeah,
I see. Okay, I think this is it. Thank you very much.